So I've added a new section here, CI/CD, so I want to talk about that today. There will be a lab associated with it, but I won't publish the lab until maybe next week. So you've got a free weekend potentially on this module anyway. So CI/CD stands for Continuous Integration and Continuous Deployment. I'm going to concentrate on the CI part in this lecture. I'll mention a little bit about CD, okay, but in terms of practicing it, that might not happen until later on in the semester in the labs. The context for this is we have a team of developers working on a project. So they're all busily developing code. They're writing unit tests for their code. They're running those tests locally, of course. They may even be running end-to-end or system tests locally as well to make sure that whatever they're developing doesn't cause any problems. But we have this problem that everybody is working kind of locally on their own machine. Now, at some stage, we need to integrate people's work into one unit and make sure that when we do integrate people's code into the overall application, that it doesn't cause problems. So this idea of integrating individual team members' code back into the overall project and building the entire application and running all of the system tests, that's something that needs to be done. And the question is, well, when do we do it? Do we do it, let's say, every Friday afternoon? Or do we do it every midnight when nobody's working on their code base? Neither of those solutions, well, once upon a time, that's kind of what happened, but not any longer really. The feeling now is that integrating people's code back into the larger kind of project and running all of your system tests or end-to-end tests, that work should be continuously happening. And the way it kind of works now is, as an individual, as a developer on a team, okay, you're developing your code locally, you're writing your unit tests and you're running your unit tests locally. You may even be running you may be running system tests locally as well. But eventually you will push your code up to a central repository, GitHub, for example, although it doesn't have to be GitHub. And when you push your code up to the central repository, what we want to happen is a separate server realizes that one team member has pushed their code up to a central repository, and immediately that central server will download the contents of the central repository, install any necessary packages that are required. So if it was a JavaScript project, then it would run npm install on the actual project to install all the third-party libraries. Run all of the system tests or end-to-end tests that have been written so far, run all of those tests and publish the outcome of those test executions on some other service, third-party service, cloud service that all of the team members have access to. And that kind of process of this other server downloading the contents of the central repository, installing all of the necessary dependencies, and running all of the system tests, that actually happens every single time a team member pushes updates to the central repository. So it is a continuous integration of people's work. This is happening almost hour by hour, potentially even in shorter time frames than that. So this is kind of a definition of what continuous integration or CI is, but I've kind of given you the bigger picture. So it's a software development process where members of a team integrate their work frequently, certainly daily, even more frequent than that, leading to multiple integrations per day. Each integration is verified by an automated build. Build in the case of JavaScript would be possibly transpiling all of the code and running tests, as I said. And the whole purpose is to detect integration errors as quickly as possible. That's the whole point of CI. If there are problems with integrating my code with the rest of the team's code, then we want to know about that as soon as possible. That definition is from an individual called Martin Fowler. I don't know if you've come across his name, but he's kind of a leading light, if you like, in the whole software engineering world. Here's another definition, but kind of saying the same thing, but in just different words. In software engineering, continuous integration implements a continuous process of applying quality control. By applying quality control there, we mean that comes in the form of running our tests and making sure all of the tests pass. Applying quality control across small pieces of effort. Sorry, now, does that read right? In software engineering, CI implements continuous processes of applying quality control, i.e. small pieces of effort applied frequently. CI aims to improve the quality of the software, and we're measuring quality. One way, anyway, of measuring quality is by ensuring that all of our system tests and indeed unit tests, that they all pass all of the time. And at the end there, I'm saying, and to reduce the time taken to deliver the software by replacing, so the traditional approach towards integrating team members' code into the larger application was to do it much less frequently, but as I said there earlier on. And it's all about trying to catch bugs as early as possible, fixing them as early as possible, amongst other things. So how do we achieve this continuous integration kind of world? Again, I've alluded to some of it. Number one, there has to be a central repository for the code base. You can think GitHub as our solution to that. Number two, we automate the build tasks. Now, like, build depends on the nature of the project, what language you're using, what platform you're using, etc., etc. In the case of a JavaScript project, build would include transpiling the code, maybe running what are called static code analysis tools across our code. We haven't looked at them. The most popular static analysis tool associated with JavaScript is a tool called ESLint. You may have heard of it. I'll cover it at a later stage, maybe. Essentially, what ESLint does is it looks through all of your source code and tries to identify poor practices in terms of your usage of the JavaScript syntax. A very simple example might be in the early days of JavaScript, the way we made a comparison check is by using the double equals sign. In any of the code that I've given you, we use the triple equals operator. And the triple equals operator is a kind of a new addition to JavaScript, and it's considered a much safer comparison operator to use than the double equals. So for example, this ESLint tool, if it finds that you have used the double equals operator anywhere in your code, it will just report that as a warning that maybe you should change it to the triple equals. And there is no case when you wouldn't really. And there are other things that these static analysis tools can do in terms of identifying poor code practice. They have nothing to do with logic now. These static analysis tools won't pick out logic errors in your code. It's only poor coding practice. Number 3, again, I've kind of said these things, that everyone commits every day to the central repository, every team member, and not only every day, but potentially every team member will be committing code to the central repository a number of times in the day. Of course, the code has to be functioning code. It has to be code that has passed all its unit tests. That's a given, I guess. Number 4, it's very important that you see what's going to be happening now is every time somebody pushes code up to the central repository, we go through a full build of the system, where build means installing all the, let's keep with the JavaScript context, installing all the NPM modules, running all of the tests, running ESLint over the code. So that's quite time consuming. So it's important that you fine tune the build process as much as you can. One example of that is by caching. You know, it wouldn't make sense to reinstall all the NPM dependencies every time you had to do a build. It wouldn't make sense to do that if the package.json hasn't changed from one commit to the next. And so we can maybe do some caching of all of the NPM modules between builds. That's one example of improving the speed of the build process itself. Number 5, when we do a push, or when a team member pushes some code up to GitHub, the whole CI process will be carried out by a separate server. And that separate server is kind of hooked up to GitHub in some way, and it will be informed by GitHub that somebody has made a commit to the GitHub repository, and the CI server will go through its process of cloning the contents of the repository and doing a build. And that server is dedicated to that purpose. Number 6, what I'm saying there, number 6 is, it's more veering towards the continuous deployment now, but ideally you should, as part of the kind of build process, you should deploy your application to an environment that is as close as possible to the production environment. And we refer to that as being the staging environment. Might come back to that later on, because we haven't talked about, for example, in the case of our movies app, we haven't talked about deploying it onto the cloud. We're always running it locally. And there are lots of cloud services that would allow us to deploy our movies app to the cloud so that everybody can then access our particular movies app, rather than just an individual being able to access it on their local machine. So I'll kind of skip over 6 for now because we haven't come across it. Number 7, it's very important that everybody has access to the results of the last continuous integration build that was carried out. And usually there are as we'll see, there are third-party services. In fact, Cypress has it. If you've used the Cypress dashboard, which everybody should have used at this stage, well, if our CI server is running our Cypress tests for us, then that server can push the results of the tests up to the Cypress dashboard, and then individual team members presumably will have authorization to access the particular dashboard or the particular project on the dashboard. So that aids this idea of the project's visibility. Number 8, make the process transparent for everyone. That kind of is the same point again, really. Why do we do continuous integration? Again, I've hopefully kind of convinced you that it's a good idea at this stage, but it's all about detecting development problems as early as possible, because the earlier we identify a problem in our code base, like a piece of logic that hasn't been implemented properly, the earlier we find it, the easier it is to fix it, and the less costly it is to fix it. The longer we leave bugs in our code base, the more difficult it is to unravel them, and it takes more time to fix them usually, because there is physically more code the longer in the development process we go through. So it's harder to actually A, debug the problem, and B, fix it. Number 2 is kind of saying the same thing. Find and remove bugs earlier. That's the objective, the whole objective of continuous integration. Reduce the risk of cost, schedule, and budget overruns. Number 4, increase project visibility. That kind of was what I was talking about there earlier on. Every time the CI server carries out a full build, it publishes the results of that build, e.g. the Cypress test outcome. And it's very important that everybody knows what has been the outcome of the last build that was done by the CI server, so that everybody in the team is aware of, you know, what's happening in the project. You could be busily working away on your own code, whatever task you were assigned within the team to do, develop a particular feature or develop a particular class, but you may not have the kind of bigger picture as to how the overall project is progressing. And so continuous integration aids that. Number 5. The other thing is, you see, what continuous integration means is that, in a sense, we always have a working version or a working form of the application. It may not be complete, but it is working up to now anyway. The features are working, and we can be kind of confident of that because we have been carrying out builds, application-wide builds and system tests almost hourly, if certainly daily. So we've got a lot more confidence that we have a, albeit maybe primitive and incomplete, but we have a demonstratable version of the application that we can show to our clients or to the customer, whoever we're developing it for. And so we can actually deliver new features to, if it's an existing application that's being used by a client base, it's actually easier for us to deliver new features on top of that application. CI kind of aids that. Number 6, improve team cohesion. Yeah. Number 7, greater availability of deployable software. That's kind of what I was talking about there. Deployable software is really, what we mean by that is software that we can actually make available to the customer or the clients, be it for demonstration purposes or that they can actually use in their everyday work. This is kind of saying the same thing really in different terms, this kind of better, faster, cheaper. That's the whole idea. So I'm not going to talk over all of these again now because I've kind of made the points already. I'm just going to say a little bit about the CD part of CI/CD. it turns out now that CD stands for two different things. So it should really be CI/CD/CD, but nobody uses that. Everybody just says CI/CD. So the CD stands for continuous delivery and continuous deployment. They're two different things though. So I'm saying their continuous delivery is the development discipline where you build software in such a way that the software can be released to production at any time. This is kind of what I was talking about there a while ago. If we are doing continuous integration, I should say now that CD is completely dependent on CI. You can't have CD without CI. We know what CI is now, we have a sense of it. And what it means is that what CI allows you as a development team or development software house to say is that you can actually deliver new features to your client in a much more kind of readily way. So I'm just going to read that again. So continuous delivery is the development discipline where you build software in such a way, and this is the last part that's important, in such a way that the software can be released to production at any time. Like the old way of doing this was we would announce today that we will release version X in 10 months time and it will have features 1 to 10. That kind of approach is gone now. The way we kind of do it is we just release new features on a very, very frequent basis. And this is because we have CI as part of our development process. And it's really up to the development team to kind of decide almost on a weekly basis, we'll release feature X tomorrow because look, it's gone through a number of builds, passing all of its tests. We're very happy with it. Let's just release it. It doesn't have to be a big announcement or we don't have to wait until a major release of the overall software. We can just release features on a much more regular basis. So continuous delivery is the potential to release new features into production at any time. Continuous deployment is where it actually happens all the time. Continuous deployment is this idea where every time a developer pushes a new update to their code to the central repository, the CI process kicks in and does its thing. And immediately, assuming the CI passes now, of course, if the CI passes, then immediately that new code is now part of the production version of the code that our clients and users are using. It's actually automatic. If you think about that now, as a developer on a team, every time you push an update to the central repository, and provided that has not caused the CI server to report a failure in its building of the application, if there wasn't any failure, then immediately that updated code has now become available, has been deployed to the production environment which our users and clients are using. Okay, that's really where we're at in modern day software engineering. So the CD in terms of how and why, again, the how is, well, number one, it's completely dependent on a software house having a very thorough continuous integration process. That's the building block. And that's it. That's essentially it, really. If your continuous integration process is well tuned and we're very confident about it, then you can almost adopt this kind of CD approach towards delivering software to your clients. And why is it a good idea to deliver new features to clients as early as possible, rather than kind of waiting for a big announcement, at the end of the year or in 6 months' time? Well, by delivering new features to our applications, to the clients and users of that application on a very regular basis, means that we can get quick feedback from the client base. Feedback that may suggest improvements to the feature, or potentially, the reality is there may still be issues. If our testing wasn't thorough enough, there may still be issues with it, but at least we can get quick feedback because we are releasing features on a very regular basis. Users are using those features, and so we can potentially get quick feedback from them as to their success or otherwise. It's kind of showing it diagrammatically. So the top one, if I bring in my pen, oops, sorry. So this is kind of describing what happens when a developer pushes an update to the central repository. The CI server does a build. It potentially actually runs all unit tests. It then runs your system tests. It deploys the application to a staging environment if you have that. Again, we haven't looked at deployment, but in other words, it just uploads your application to some cloud service that will run your application. Then you run all of your, I'm saying acceptance tests here, but it's really your kind of system tests, your end-to-end tests. You run your end-to-end tests against the application that has been deployed to the staging server. So that's what proper CI is all about. CD is where you continue on that, and you decide manually whether once the acceptance tests have all passed for a particular integration, you might decide, I'm actually going to release this version of the application out to the client base or user base. So it's going to be deployed into production, as we say. But that step from here to here is a manual step. Okay, that's what continuous delivery is really all about. And it's up to the project manager or team manager to decide when this should happen. Whereas continuous deployment, the move from here to here is automatic. Okay, so obviously any software house that are practicing continuous deployment, they've kind of moved through these phases. They were doing CI only for a number of years, possibly. Then they moved on to CD, and because things were so successful in the sense that we found that we could take the manual release on a very regular basis, then they eventually evolved into continuous deployment. But it takes a long while for a software house to get a software development process that is so fine-tuned that they can actually follow a continuous deployment practice. But there are lots of them out there that do. Back to continuous integration, which is really the focus. So it's okay. It's not enough just to be doing continuous integration. It has to be successful, and so there has to be metrics that you use as the kind of manager of a software development team. There have to be metrics related to CI that you use to kind of determine, is our CI process good, and if it isn't, how can we improve it? You certainly wouldn't go back to not using it, but how can we improve it? So it's very important initially when a software house starts practicing CI. I'm saying here it's very important to pay attention to the actual builds and making sure ideally every build should be a successful build, as in all of the tests pass, and the deployment of the application to the staging environment, not to the production environment now, but the deployment of the application to the staging environment and the running of the system tests against the application running on the system on the staging environment. All of that is successful almost every time you do a CI. That's the ideal scenario, but of course that's not the reality. And so I suppose what I'm saying here is, first of all, you need to pay attention to the actual builds. It's important that they provide immediate feedback in terms of their success and failure and why they're failing. And well, okay, skip over that, but the metrics then, as the kind of project manager, I suppose, on a team, it's important that they identify what are the key metrics that they are going to track to determine whether their CI process is a good process or not. And if those metrics are telling us that our CI process isn't, then we need to act on it, because otherwise the whole CI practice is a waste of time. Because if the CI builds are failing on a very, very regular basis, that just doesn't improve the whole software development process at all. Metrics, what do I mean by CI metrics? I mean, the simplest one might be, what's the success rate of our CI builds? You know, do they fail on a kind of daily basis? That wouldn't be great. And then whatever is causing the builds to fail, we need to identify what is the cause of it. You know, are people writing, pushing untested code up to the GitHub repo? I mean, that would be a simple example, a very simple example, but there might be other reasons as well. So we need to identify what's causing our builds to fail and try and resolve them. Other kind of metrics I'm seeing here might be, how, once a build fails, how long does it take the team to work out what caused the failure and fixing the build failure? Is that a matter of seconds or minutes, or does it take days? And again, that if it takes days, then we need to investigate further as to what are the issues that are causing the build failures to keep happening, and why are they so difficult to resolve. And there are other metrics as well. The last two metrics there relate to how good your testing is. I haven't mentioned this idea of coverage. If you think about when we wrote unit tests, or even our Cypress tests, but let's stick with the unit test. When we write a unit test for a method, let's say, or maybe a class, what I mean by coverage is, has the unit test that we've written actually exercised every single line of code in that class? If it has, then what we say is that the test has achieved 100% coverage. In other words, there's no part of the class code that wasn't actually executed during the execution of the unit tests. And what you're aiming for, obviously, is maximum coverage for all of your unit tests. And you'd be surprised that you might think you've written good unit tests, but when you actually measure this coverage metric, you find that there are actually certain parts of the code base that were never actually exercised by the tests. They usually relate to these kind of boundary tests and edge tests and exception testing, that you haven't actually done enough testing of those parts of the unit that you're developing. Again, we might touch on it later on, because there are tools that can actually report on this kind of coverage metric for us. We don't have to do it ourselves. The same applies to our end-to-end or functional tests. How do we know that we've actually written our Cypress tests in such a way that every single part of my React app, if it's a React app, every single line in my React source code has actually been executed at some stage by some Cypress tests? In other words, what has been the coverage of associated with my Cypress tests. And again, we hope we may not look at that, but I will come back to the unit test coverage, but it's the same kind of idea. So these are all kind of metrics that a software development team needs to monitor. Well, a subset of them, they would choose which ones they think are the best one, and then they would monitor them on a very regular basis for each CI build to make sure that we are meeting our kind of objectives in respect to these metrics. That's all theory. We have to do something at some stage. So the tool or the platform that we are going to use to practice CI, and it is going to be CI we're going to focus on for now, is a platform or service called GitLab. And what GitLab is, it's a cloud-hosted platform that facilitates team collaboration, which is what CI really is all about. It's completely open source. It's free to use. There is a you could actually run it on your own desktop as well, but we won't do that. We'll use the cloud-based version of it, and it's very actively maintained. Now, GitLab is that there are a lot of parts to it. Really, it's more than just CI. It kind of covers the entire project management, if you like, areas or other areas of project management other than just CI. And that's what I'm showing in this diagram here, but we're only really concerned with this part, with this part. Turns out that what GitLab is essentially, it has a number of parts to it. So number one, GitLab has its own Git repository. This is essentially an alternative to GitHub. It does the exact same thing. It's a central repository, cloud-based Git repository service that we can use, and we will use that. So we won't be pushing our code up to GitHub. We will be pushing it up to a GitLab repository, but it's the exact same principle. Now, in addition to that, GitLab has a whole CI part to it that we will be using, but it has these other elements as well, which we will stay away from. And these other elements relate to other aspects of software development, like issue boards. Like issue boards would be used by software development teams and indeed users and customers to report issues that they are having with the particular application or application. User management is straightforward enough. I suppose we need to administer who in our team can access the repository and the CI part. So authorization rights management, that's what's going on here. Container management or container registry. I'm not sure if you're familiar with Docker containers, but there's an entire Docker registry part to GitLab. And then there are other aspects over here. So for now, we're only interested in these two here. We don't need to spend that much time on this because, as I said, it's essentially just an alternative to GitHub. This is where we're going to spend the majority of our time. So GitLab CI is one part of the GitLab suite, if you like. And by now you know that what it is. Well, what's nice about it is that it's fully integrated with the GitLab repository. In other words, these two parts are fully integrated. So what we will be doing is we will be pushing the Movies app. Actually, we'll create a repository up here for our Movies app, and every time we push to that repository, we will initiate a CI build of our Movies app. And the CI build will involve transpiling all of the code, running a local little server, and running our Cypress tests. And maybe later on then, if the Cypress tests all pass, we will automate the deployment of our Movies app onto some cloud service where everybody can actually use it. So GitLab CI, I'm saying there is fully integrated with the GitLab repo, the way that I explained there. What we will actually be doing is we will be writing our build scripts, and the build scripts is what GitLab CI uses to work out, well, what exactly is involved in building this particular project, because it won't know whether it's a React, whether it's a JavaScript project or a Python project or a Java project. It's going to follow the script that we provide. And the script is actually just code. Well, sorry, it's a file. It turns out to be a YAML file, but it's a file that will be part of the repo. Okay, so it will be subject to Git kind of management, if you like, Git version control. Git hooks, that's okay. It's free. That's all right. So in our repo now, we'll have our source code and we will have our build script. The build script will just be a single file, but it'll be subject to version control, as I said, and all of that. That's okay. So this is the language of GitLab CI, and in fact, if we were using, there are lots of hosted CI services out there. Jenkins is one that's very popular. Travis is another one. I think I would have used Travis maybe about 2 years ago on this module, but I've changed it over to GitLab because I think it's a little bit better. So the terminology that we're going to talk about, use here, there isn't a whole lot of it really, is the same terminology that you would use for the other cloud-hosted CI services. So it's all about pipelines, stages, and jobs. And I'm saying a pipeline is comprised of a number of stages, and a stage is comprised of a number of jobs. In a lot of our cases, a stage will only have one job. So what you do in your build script is you describe what is the pipeline associated with building your particular project. And you will describe it in terms of the stages that make up the pipeline. And for each stage, then you will specify the job that is part of that stage. And so I'm saying here that a pipeline is a group of jobs that gets executed in stages or batches. Okay, all of the jobs in a stage are executed in parallel, but in most cases, we would only have one job per stage. The stages are executed in a particular sequence, and you have to tell GitLab CI what is the sequence in which it should execute the stages. And the stages that make up the pipeline, as I said. Now, where do we actually describe the pipeline for our project to GitLab? Well, you actually put it into a special file with this name, and it's a YAML file. Don't know if you've come across the YAML file format before. It's very straightforward. And so what happens now is when we push our Movies app project up to GitLab repository, the GitLab CI server will look for this YAML file, and it will use that then to initiate a complete build of your application, where we can now say a build is a pipeline comprised of a number of stages, and each stage potentially has a number of jobs, or certainly has one job. A job might be run the E2E tests, run the Cypress tests, for example. So it turns out that this this YAML file, there's very little in it actually in terms of physical size. So it's more declarative than procedural. The GitLab, I suppose I should just flip over to the browser. Here's GitLab, and so what you will do is you will create an account for yourself on GitLab, just like you would have on GitHub, for example. And then you can go to your projects. And so I've got some projects here, and you'll recognize this one. Okay. And here we go. Here's the GitLab repository side of it. So it's telling us, you know, that looks similar enough to GitHub. Over here then are all of the other aspects of the GitLab platform. And notice here one of the aspects, so sorry, all of these here kind of relate to these other areas here. We're particularly interested in this one, as I said, and here's the CI/CD part. And if I click on it, I can see what pipelines do I have, what pipelines, sorry, not what pipelines do I have, what pipelines have been executed for the particular project that I'm looking at. The particular project that I'm looking at is the movies app one. And it looks like I have ran my pipeline twice. The first one failed, and the second one passed. If I come across here, this is kind of how, this is telling me that the pipeline had 3 stages to it. The first stage passed, the second stage passed, the third stage failed. Now, I happen to know, but you'll see in a while, the first stage was just concerned with running npm install on my project, installing all of the node modules. Because remember, in my repository, all I have is the source code. I don't have the npm modules. We never upload our node modules folder to GitHub or to GitLab either. So that just runs npm install, and it was all successful. This stage actually transpiled my React code, and this stage ran the Cypress tests. And so some of the Cypress tests must have failed. We can actually dig into it. We'll do that maybe the next day. The second time I ran the pipeline, looks like it all worked. Sorry, that failed as well. That wasn't very successful. So there were still some problems with my Cypress tests, or with my source code potentially. Maybe I should pick one out that is successful. Okay, so this one passed, and coincidentally, this has 3 stages as well, but that can be any number of stages. Now, I'm aware of the time, so GitLab has a nice kind of web UI side to it, which we will be using a lot. This is kind of explaining what happens, which I've kind of already done in passing, but if we look at the diagram kind of, so here you are working on your source code on your desktop in VS Code or whatever. You push your code updates to, in our case, we're going to be pushing it up to GitLab repository, but you could also use GitLab with GitHub. You can integrate them, but we're using the GitLab repository for simplicity's sake. And straight away, what GitLab CI will do is it will notice that you have pushed to the repository, and it will, on a separate server, and it will find an available server, it will run what's called the GitLab runner. So the GitLab runner is kind of the platform in which it runs your pipeline. Okay, I'm just telling you a little bit about the GitLab runner here. You don't need to worry much about it. It would be important if you wanted to run GitLab CI on your own machine, which some software houses do. They don't want to run GitLab on the cloud-based service for security reasons, I guess. So you can run the whole GitLab platform on a local in-house server. But essentially, anyway, what GitLab does is it runs the GitLab runner on a particular machine, and that runner then becomes the platform on which to execute your pipeline. Okay, so that's what's happening. It kicks off the runner. The runner is written in a language called Go, which is a very high performing language. And then it goes through the process of, I'm saying here, the first thing it does is installs your dependencies, but that depends on your YAML file. Docker is a big part of GitLab. Again, I'm not sure if you're familiar with Docker or not. You may not be, but it's there in the background anyway. So what we will be doing is, and I'll kind of wrap it up now fairly quickly, we will be adding a GitLab ci.yaml file to our movies app React project. This is I'm showing you excerpts from the GitLab YAML file. The very first line, typically, you've got to tell it what kind of OS platform and other dependencies do you need. So what this is actually saying is, I need the platform, I need the Node platform and this version of it. I also need to have Cypress, and I also need to have a browser. So what this is actually referring to is a Docker image that is going to be loaded onto the CI server that is going to be running our tests. You must remember now that, I suppose you could think of it as a virtual machine instance, although it's slightly different from that, but it's similar to a virtual machine or VM instance. That's what you're kind of specifying here, and what exactly you want that virtual machine to contain. In my case, I want it to contain Node. I also wanted to have the Cypress binaries installed, and I needed to have a particular version of the Chrome browser installed. What this is telling us is this is essentially a definition of your pipeline. Remember, a pipeline is a sequence of stages, and so here they are. The syntax here is very important, obviously, and as well, because this is a YAML file, the indentation and alignment is also extremely important. So you've got to be very careful about that. So that's my pipeline, and then here I'm showing you just some of the stages. The install stage does very little. It just runs npm install, that's it. So we know what that command does. What it's doing here, though, is it's installing all the Node modules on the image on the VM virtual machine that was started up for us by GitLab CI in order to run our tests. This is the stage that actually runs the Cypress tests. Again, we've covered this in the lab, but what I'm actually doing here is I'm installing a little HTTP server. I don't run the React development server up in GitLab CI. You could, but it wouldn't be the best idea. So I'm doing it slightly differently. Now, I didn't expect to get through all of these slides, and that's okay. What I will try and do maybe is have a lab covering this stuff available for you maybe Monday, Tuesday of next week, and you can work your way through it. And we'll finish off, there's only really one more slide, 2 slides in this sequence, but obviously this is the important part, and understanding, interpreting, this code is important as well. That's what it's all about, really. And I haven't talked enough about it to expect you to understand it at this stage. I wouldn't worry about that. Right, that's it for now. So in the meantime, as well, if I just quickly go over to Moodle, you will notice that there is a section here, and I've put up a specification for the first assignment, and that assignment will run until pretty much the end of the semester. There is going to be a second assignment, and that will run over Christmas, and you will be submitting it in January. If you want to, you can have a look at the specification, but again, I need to talk through it with you because the specification does include some material that we haven't covered yet. It's mainly about Cypress testing. It's about CI, which we've just been talking about, and it also it covers a topic called bundling or code splitting, which I haven't covered yet. Right, that's it for now.